This is Steve Piloff from George Mason University, and now we'll get into the guts of compounding by talking about rates and how they're presented and how they're computed. There's two different ways that we frequently express annual rates. The first is as an EAR, which stands for effective annual rate, and the EAR reflects, it takes compounding into account. So it reflects the effect of compounding, and as a result, it reflects the actual or true rate that you would earn on an investment or that you would pay on a loan. So because it takes into account compounding, you can think of this as the actual or true annual rate. The second rate is the APR, the annual percentage rate, and this rate is quoted by law, so that's the main reason why it exists. It does not reflect the effect of compounding. So as a result, it can be a little bit misleading, and the effective rate is the one that one would rely on in making decisions, but the APR is one that's often out there and it's what's often presented, and so you clearly want to be familiar with that. Stated rate and quoted rate, those refer to an APR. So let's look at some of the formulas. Or before we do the formulas, let's talk about that loans with a lower EAR have lower costs because the EAR reflects the true cost of a loan. So again, if we're going to have an example, if we're comparing loans that all else are equal, what we would want to do is know what's the EAR for this loan, what's the EAR for this one, and the one that's lower, that's the more attractive loan because it has a lower rate. If we had two investments, we would want to compare their EAR to know which one would we expect our wealth to grow more over time. And just a quick sidestep when we get into bonds and stocks, if two items that you're comparing have the same compounding frequency, then the one with the higher APR will also have the higher EAR, and the lower APR has a lower EAR. So if we're comparing two assets or two investments that have quarterly compounding or semi-annual, we can make an assessment as to which one has the higher or lower EAR simply by focusing on the APR. Now, if there's different compounding frequencies, then you can't just look at the APR, but you can save yourself some work because whatever one has the higher APR is going to have the higher AAR if they have the same compounding frequency. All right, so now let's get to the equations. The APR is simply the number of periods in a year times the periodic rate. So if we knew what the monthly rate was, and we know there's 12 months in a year, we would just multiply the monthly rate times 12. Likewise, if we want to find the periodic rate, you just take the APR, which is the rate for a whole year, divide it by the number of periods in a year, and that's the periodic rate. So if we had the annual rate and we want to know the quarterly rate, it's an APR, just divide by 4, 1, 2, 3, 4 to get the quarterly rate. That's why in the example we looked at in previous lecture, when it's an APR of 8% or an annual rate of 8% and it's quarterly compounding and the periodic rate was 2% per quarter. EAR takes into account compounding. So you have 1 plus the periodic rate to the power of the number of periods in a year. So if it was quarterly, you would have 1 plus the quarterly rate, and since there's 4 quarters, it would be compounded to the 4th, or 1 plus the monthly rate to the 12th. So, APRs are easier to work with because it's just multiplication division. Here you have to take things to the proper power in order to make sure to take into account interest on interest. If you want to back out the periodic rate, you have 1 plus the EAR, which is the annual rate, but it got there through compounding, so you take it to the power of 1 over the number of periods in a year. The two formulas that we would use most are this one and this one, because you're often given an APR, and then you need to get the periodic rate, and then use that to find the EAR, which is the rate that gets used in decision making. And so here are just some equations that, if you have the APR, you can divide by the number of periods to get the periodic rate, 1 plus it to the power, and just like here, APR, you do this to get the quarterly or the periodic rate as expressed here, and just multiply by the number of periods in a year. And you can see from our example, remember we had 2% and we went from 100 to 108.243, that if the APR is 8%, the quarterly rate's 2%, and the EAR would be 1 plus the quarterly rate to the fourth power minus 1. Basically, the reason it's minus 1 is that number, 1.02 to the fourth, if you had a dollar, if you owed a dollar or had a dollar, and it accumulated 2% interest for 4 quarters, that whole expression would capture how much you have. You pull out the 1 and you're left with just the rate part. So notice the minus 1 there. And it's 8.243, which is consistent with the fact that you owe $8.24.3 when you owed 100. You owe 8.243% more, and so you can see the equations get us there, and it's consistent with when we kind of walk through it step by step by step. So this is a useful reference. APR of 9% compounded quarterly, that's equivalent to 9 divided by 4, which is 2.25% per quarter. Those are equivalent. If you saw a problem, as we'll talk later, if you saw a problem with that, that's equivalent to that. If you had an APR of 9% compounded monthly, that's equivalent to a rate of 0.75% per month. And so here you can see they both have 9%. The EAR, when you got 2.25 per quarter, take it to the fourth power, is 9.31. When you have 75 1/100% per month, so you take it to the power of 12, you wind up with different EAR, 9.38. So again, highlighting that compounding period, compounding frequency is important. So if a rate's given, assume it's an APR, unless you're told it's an EAR or a periodic rate. And again, periodic rate just means unless you're told it's 3% per month, or quarterly rate of 4%, or semi-annual rate. Otherwise, it's an annual rate, and if it's an annual rate, it's APR. Stated or quoted means APR. And again, so if a rate's given, 4%, 7%, 9%, and that's it, assume it's an annual rate. Specifically, assume it's an APR, unless you're given explicit information that it's one of those two. All right, so let's look at an example. You're getting a loan. There's two choices. A has an interest rate of 7.32% compounded monthly, and B has an APR of 7.40% with semi-annual compounding. Which one would you prefer? Well, the naive person would say, oh, I'll just take A because it's got a lower rate. But you're more sophisticated. You say, wait, we got to make sure we're comparing the correct rate. And in order to that, to compare the correct rate, you need to find and compare the EAR, because that captures the fact that compounding can have an effect. And this one has more frequent compounding, this one has less frequent compounding. So we don't know whether that's going to make the 7.32 less attractive than the 7.4, even though it's got the lower APR, depending on the effect of interest on interest. So let's find the EAR of loan A. We're assuming that the interest rate is an APR because it simply says interest rate, which doesn't specify what kind of rate it is, doesn't specify the time period, so we assume it's a year, therefore an APR. So if it's 7.32% compounded monthly, we're going to need the monthly rate, and then 1 plus that to the 12th. So our monthly rate is 7.32 divided by 12, which is equal to 61/100%. That's the rate that we would get hit on in this loan every single month. You have to take it to the power of 12 to take into the fact that you're going to have interest on interest. And so the EAR is 7.57%. If we borrowed $100, a year later we'd owe $107.57 if it was, get 100, pay everything back at the end, or don't make any payments along the way. How about loan B? Loan B, APR of 0.0740, and it's semi-annual, so that's 3.70 for every half year. There's 2 half years in a year, so we have to take it to the power of 2. The EAR on loan B is 7.54. Guess what? Loan B is more preferred than loan A. It's got the lower EAR. So even though it's got the higher APR, when we take into account the fact that semi-annual compounding reduces or limits the number of the amount of interest on interest, while 7.32 with monthly compounding, it has more opportunities for interest on interest, that actually has a larger effect, making A less attractive than B.